Everyone. This is Sam from New Smart Economy. Today, we are glad to invite Shargan, the founder of Red4Sec, to, to share a workshop named Scopes and Permissions. Hi, Shargan. Could you introduce
Hi.
yourself first?
Yes, of course. Hello, I'm Fernando, known as Argon. I've been a developer more than 15 years, core developer in NEO, ethical hacker, and founder of Reforce Cybersecurity. And in this workshop, we are going to discuss the different protection measures that NEO has to protect the calls and in our smart contracts.
Thanks.
Let's start.
Yeah, you can start your workshop now, I think.
Okay, cool. This will be the index of what we are going to see over the next minutes. We will do a proof of concept for each with NEO Express. The first point will be the witness scope and witness rules. Witness rules is a kind of witness scope. The second point, it will be the read-only nested arrays, because we already see that in our audits that people don't use read-only when it's necessary. So we think that is important. The third point will be the call flags for external contracts of calls. And the fourth point, it will be the contract manifest. And in this contract manifest, we will see the permission and trust. Let's start with the first point, witness scope. In each transaction in blockchain is protected because it's protected with a signature, with a cryptographic signature, and it's verified. Its signature verify the sender. Some blockchain, like Ethereum, allow a single cryptographic signature, but in NEO we have multiple signatures. Each transaction can have 2, 3, or more signatures. And this signature is protected by a scope. This scope indicates how they must use and validate this signature in our contract. So we can choose if our signature can't be used in the smart contract with a known witness scope, or we can set the scope as called by entry. That means that the signature, it will be only valid if we comes from the entry point. We can set the signature for custom contracts is a array of which contracts can use our signature. Only this contract will return true in the check witness scope for our signature. This will be the same with custom groups, but instead of contracts, it will be the groups, because in the manifest we can set the group of our smart contract. We can set a public key and define that our smart contract is of this group. So if we define the scope of our signature only for this group, it will be valid only when it's checked by one of these contracts. And a more complex one and a more new one is the witness rules that we will see later. Let's start a proof of concept with NEO Express. Okay, it will be the first proof of concept. We will share the GitHub link with all of the samples and also the PPT later in the chat. And this is our sample smart contract. Okay. We already see in other workshops how to code a smart contract in C#, so I will only tell which method we define it. We have the check witness method. Is a safe method. So safe means that in the method we don't alter any storage. So this method receives the hash that we will check if is valid or not. For return true, the signature must be signed with this hash, but also with the right scope. And we have another method to make an external call in order to check the different witness calls. Okay. We will start Neo the blockchain. The Neo Express. And we will deploy the smart contract using deploy contract to Neo Express. From the wallet Genesis, this is the NEF. And we need to wait the deployment is successful. So now we can call the smart contract. Using for make the call simple, we already made the invokes that we will do it. Okay. The first will be the regular invoke. In that invoke, we will call the our smart contract sample witness because it's defined with this name. And we will call the method check witness. First with the argument Genesis, and second with the argument Neo token. So we will check if the transaction is signed, is well signed with Genesis, or is well signed with the Neo token. We will have access to the Genesis wallet, so it's easy. But we don't have access to the Neo smart contract web, so we will receive false. Okay, let's do it. If we do the call and we sync the transaction with, I will start. If we use the Genesis wallet, it's the same on this one, and we sync the transaction in called by entry or global, we will return true. And if we sync with none, we will return false. Let's check with the called by entry. And the second always will be false. It don't care how I sign because we don't have the signature of Neo token. Let's check. The first one is true, and the second one is false. Always, this one always will be false. This is true because we signal with called by entry. If we do the same with global, it means that any contract can use our signature. So we will have the same results in the proof of concept. Let's see. True in the first one, false in the second one. Now we will check with the non-call flag. If we use none, it means we see in the transaction with the Genesis wallets. Okay, we choose Genesis for SYN, but we use the non-scope. So there are not the contracts can use our signature. So we will get false and false. Let's see, false and false. The contract can access to our signature. The transaction is signed with the signature, but the contract can access. So it will this method will return false. And now we will check with this is the regular inbox. Okay, we only call this method. Now we will check calling to the or a smart contract. It's like if we simulate an external call. It's like another contract called this method, because we call the same execution script, that is this contract, to the method check witness with the call flags none. This call flags we will see later, so we don't need to know nothing about it and the same argument. So this call will call the check witness method of our smart contract, but it comes from the same contract, not the entry point. Basically, this comes here. Wallet genesis is the same. If we use called by entry, that in the first example it will return true, now we will return false. Why? Because the caller is not the entry. The caller is the same smart contract. So in this and in this, we will get false. False. And if we use none, we always will get false. It doesn't care if it's an external call or a direct entry call. And of course, if we use global, it means that it can be used. So the witness is true. That was our samples with the check witness and the witness call. If anyone have any question, you can use the chat and we will answer you later. The next point in the workshop, it will be the witness rules. The witness rules, as I said before, is a type of scope more complex and allow us to define different rules. For example, we can define a rule that specify that our signature must be valid only if it comes from a gas transfer and the entry point is our decentralized exchange. This is an example. So we can use the combination of unconditional, Boolean, called by entry contract. This is the different rules that we can combine in order to check our scope. It's more complex. At this point, NeoExpress, we don't allow it, so we can have the proof of concept with NeoExpress. So if anyone have any doubt with the witness rules, they always can use the chat and I will answer it. But it's more or less, it's a kind of witness scope. Okay, it's the witness rules. But when it's this scope, we can also have different conditions. In the PPT that we will share later, we will have all the links to the different GitHub files to check the data or payload that we will need to create this kind of conditions. So we will start with the next points. The next proof of concept, we will merge this point and the next one because are very similar. And this is the React-only storage. Using the minimum permission possible is a must in terms of secure development. In the case of storage access, we must remember that there is a method to obtain the React-only context, which will prevent any write access to it. So when we need the storage context in our smart contract, we can use the get context or get read only context. They are very different. These methods are different because one allows us to write in the context and the other one doesn't allow it. We have the links here, and we will see the proof of concept with the next one. We have the call flags. Represent the operation allowed when a smart contract is called. When we call as an external contract, the permission of this execution context will be defined with these flags, with the call flags. Here we can see the different types of permission when we call in an external contract. As we see in the previous example, we use non-flag because in this execution, we doesn't need states or calls or notifications. Sorry. If we set the real estate call flag, we can combine it. For example, states combine the real estates with real estates. We had only combine real estates and allow call, all combined all together. So it's a flag, okay? We can combine it. So if our external call must need to read the state, we need to define the real estate flag. If our external call must need to write the state, we will need to define the write state flag. Usually also the real estate. It's difficult to write without read. It's possible. If we will need to call an external contract in our external contract, we will need to allow this execution to call an external contract with this flag. If we want that our external contract can notify the execution to make a log or something like that, we need to allow the notify flag. And as I said, we have three different combined one, that is states, read only, and all. Now we will have a proof of concept with the different states. Okay. I will restart the blockchain. And start from the beginning. This is our example, our next example. Now is example.calflags. I will make the deploy. Waiting for the transaction. We can see that the deploy was made because Neospress notified us with a notification. And also, if we see the logs, usually we will see that the one block comes with one transaction. And usually, it must be or one transaction. It's the same of the deploy. So now we are deployed the smart contract example is this one, and we have 4 methods. One, as we see before, is an external call for main external call to our smart contract example. But this time we will allow to define the method and the flags. Because this method doesn't have argument, we doesn't need to specify the arguments here. Now we have a write text example. We get the current storage with this prefix and try to write in my key test. We have another example when we try to make the same, but we use a real only context. It's a different one. Okay, we have read-only context. And we have the third method is safe because it don't write in the threads, so it's good to define it as safe. And this method reads from the same key and try to read the key. Okay, we will try with these 4 execution flows. The first one, it will be here. It will be there. We will try to call the call me method with the method react test and argument 1. Argument 1, as we see here, argument 1 is the react state. Okay, because this is 1 in integer. 1, 2, 4. Okay, so if we set 1 here is the call flags, we say that it is the react state. So we want to call react test to call me. Always we will use this call because we want to define the external call. Okay. So we want to call me, this method, and use the method react test and argument react states. This will call react test with react state. So we will return null because we don't call these methods first. So we need to write to get the key, but we will try it. In this point, we can use none because we don't use the signature for nothing. So it doesn't care. Null, but the execution is root. Now we will try to call the method write first with let's try this one. Sorry, we will call write test with method react states. It will fall because we will call this method, but the flags, it will be the react state flag, and we need the write states. So this call must fall. You can see here in the log that cannot call this syscall with the flag react state. It's the same exception that we get here. Now we use the call write states is the number 2 or 3 because we can combine with real state. We will write okay. We will call write test and it will success. I need 3, sorry. I need states, react and write. Because current context require the react state, and this require the write state. So now we get a true null, but it's written. So if we call again to react state, this transaction was good now. The first try was null because we never called before to write, but now we get tested. Okay. And now we will try to call the react test with only react context. Is this method? we will try to write, but we will use a read-only context. It must fall. You see, it fall. The transaction fall. And of course, if we use write and test, we will get the value. But we already see the difference of the different call flags. Here we will get tested because first we write and second we read, so we get tested. So in this example, we see how call flags will affect if our external call is allowed to write, is allowed to read, is allowed to call an external contract or notify. It's important. People usually use the call flag all, and this is a bad. It's not recommended to use all. You always must set the minimum call flag required for your execution. Otherwise, maybe you allow an external contract to write when it's not necessary, and you are open a door to a possible vulnerability. So if anyone have any question, we can see the chat. You are not seeing the smart contract code? Only see the presentation. So I will make the pop again. So maybe I need to minimize the presentation to see the code. Now you see the visual code.
No, we can't see the VS Code. Maybe you can share your VS Code via Zoom setting.
Now you see the.
Yeah, I can see now I can see the code now.
Sorry for the mistake. Wait a minute. Demo effects. This one. We have different witness scopes. We have called by entry, custom contract, custom group, witness rules, and all. We will try with a different one. So we have two methods, one for check witness and one for check witness, but with a external contract. This, as I said before, we want to try to call from this contract to this contract again, but using an external call. In this way, we can check if it's the entry point or not. The different invocation that we have, that I defined here, is a regular one, check witness with Genesis, check witness with new token. It will return true. It depends on our scope defined in Genesis, and always it will return false. So if we try with none, we will get false and false. If we try with global, we will get true and false. And if we try with called by entry, we will get true and false. Called by entry. Why is true? Because the entry point is our Genesis account, so it will return. It's our script, so it will return true and false. As I see, true and false. Now, if we use global, we will get the same result because it's a direct call. We will see that with an external call, we get a different result. Now we get the same result, true and false. And if we use none, we will get false and false. False and false. And with an external call, now we want to use check witness with call, is this one. And this one we call this method. So it's an external call. Now called by entry will return a different value, but global is the same and none is the same. But we will see the difference with called by entry. If we use global, we will get global, we will get the same result. And if we use none, this is the global one, we get true because we use Genesis. This is the none. We will try again with none. This is the none. We get false. And now, if we use call by entry, we will get false. Why? Because it's an external call. The entry point is not the execution part. So we will get false. By this way, we can see the difference in called by entry and global. Also, we already explained this one and witness rules. I will repeat the proof of concept of storage context and call flags in order to allow you to see the code. Sorry for the mistake. Call flags is this one. Now you see the code. I will deploy the. I will restart because blockchain. Start with 10 seconds. This is the example that I saw you before. We have two write methods. One with real that try to write with read only context. Okay, read only. So this method always will fall. It doesn't care the class that we use, but because we are trying to write read only storage. This method try to write using the right context. So this method will work depend on the call flag that we define. And the method read test will work again depend on the call flag that we use it. We'll deploy the contract. And let's see the example that we are defining. First, we will call the read test. So with the call flag one, it means read state. Okay. This call flag is read state. Because when we call me read state, we are calling this method with read state and read test method and read state call flag. And this we call this method with this flag. So it will work. But the problem is we never write nothing. So we will get null. First, we need to call write test in order to have something. So we get null. If we call write first and read later, because it's a direct call, you can see the call me. We are calling this method directly, so we never define the call flag. It's not an external call. It will write and it will read. It doesn't care the scope of the signature in this proof of concept. No. So we want to know to add another step, for example, example call, and we want to make an external call to the React test with the call flag states. Now we will do two external calls. One to write with states call flags and another one to read the state with states call flags. This is a write execution because the two external calls have the writes minimum required for the execution, and we will get the result, my key. My key. Test that. So by this way, we can define how the external execution will allow or not allow different writes. And that's the two proof of concept that we already didn't see. So we will continue now. And we will continue with the contract markers. I will check the chat again, sorry. There's a question. Okay. The contract manifest. When we develop a new smart contract in any language, a manifest like this, manifest like this, is generated that contains information of certain permissions that the contract will have. We will see the permissions and the trust. There are more information. Here we have the name and the group of the smart contract that we see previously. Different feature and supported standard. The ABI is longer, so I reduce for the PPT. The different permission that we will see is very important. For example, here we allow the different native contracts. I think this is STL leaf and this is a crypto leaf or something. But there are two native contracts because we made the different calls to this native contract. If we don't set this permission, we are not able to call them. So we will start with permission. The permission section allows us to define which contract can call our smart contract. If the call is not defined within the values of the manifest, the execution will fail. We will see a proof of concept, and we have more information here and the link. But always we understand better with a good proof of concept. When we compile the smart contract, as I said before, we get a manifest. In this case, the manifest of this smart contract is this one. I will show you expanded, sorry. This one. You define the method ping, the update manifest, the external call ping, different permission. As you can see, I added here a contract permission for allow to anyone to call ping. This is this permission. So we